Have you ever wondered how the Kube API server works? Well, let's embark on this journey of discovery together. Kubernetes, often abbreviated as K8s, is an open-source platform designed to automate deploying, scaling, and managing containerized applications. Imagine you're trying to coordinate an orchestra. Kubernetes is the conductor, ensuring every instrument plays in harmony. Now, where does the Kube API server fit into this symphony? It's the front end of the Kubernetes control plane. Think of it as the maestro's baton, directing the flow of information, orchestrating the performance. The Kube API server processes and validates REST operations, updates the corresponding objects in etcd, and then it's the Kubernetes components' turn to perform their specific tasks. Kubernetes and the Kube API server together form an integral part of managing modern applications, ensuring they run smoothly and efficiently, just like a well-conducted orchestra. Now that we've set the stage, it's time to dive into the workings of the Kube API server. The Kube API server is a complex piece of software with a well-thought-out architecture. Now, let's dive into the architecture of the Kube API server. It's like the brain of the Kubernetes system, processing requests, managing resources, and communicating between different components. But how does it do all that? Well, the answer lies in the elegance of its design. The Kube API server is designed to scale horizontally. In simpler terms, it can increase its capacity by deploying more instances. Imagine a busy restaurant. When there are too many customers, the restaurant can simply open up more tables or even expand into a new room. The Kube API server does something quite similar. When the load increases, it doesn't get overwhelmed. Instead, it just adds more instances to handle the increased requests. This horizontal scaling is a critical aspect of the Kube API server's architecture, allowing it to handle requests from a large number of clients without a hitch. It's like having an army of servers, all working together in harmony to ensure smooth operation. But that's not all. The Kube API server is also designed to be stateless. This means it doesn't store any client-related data from one session to another. Think of it as a diligent librarian who doesn't remember what books you borrowed last time, but will always find the right book you need now. This statelessness not only enhances security, but also makes scaling more straightforward. Moreover, the Kube API server is built to be extensible. It's like a Lego set, where you can add or remove blocks as needed. This extensibility allows it to adapt to different use cases and evolving needs, making it a highly versatile part of the Kubernetes system. In essence, the architecture of the Kube API server is a testament to the principles of scalability, statelessness, and extensibility. It's a well-oiled machine efficiently managing requests and ensuring the smooth operation of your Kubernetes system. With a grasp on the architecture, we can begin to understand how the Kube API server processes requests. The Kube API server serves a crucial function in the Kubernetes ecosystem. At the heart of this system, it's the gatekeeper, the bridge, the translator, and the validator. But let's break this down to understand it better. Firstly, the Kube API server exposes the Kubernetes API. This means it's the main point of contact for all administrative tasks, whether they're done manually or automated. It's like the front desk of a hotel, receiving all kinds of requests from different guests, then forwarding these requests to the right department. Now, let's talk about processing REST operations. REST stands for Representational State Transfer, a standard for designing networked applications. Think of it like this: you're at a drive-through restaurant. You place your order, which is received, processed, and then fulfilled. The Kube API server works similarly. When a request is made, like deploying an application, it's received by the Kube API server, the drive-through in this case. The server then translates these REST operations into etc operations. etcd, for those who don't know, is a distributed key value store that Kubernetes uses to manage its cluster state. It's like the kitchen in our drive-through analogy where the order is turned into a meal. But wait, there's more. The Kube API server also validates these operations. It checks if the request is possible and adheres to the rules set out by the system. It's sort of like the fast food worker who checks if your order can indeed be prepared as per your special instructions before it's sent to the kitchen. This process of receiving, translating, and validating requests is continuous, ensuring that everything runs smoothly and according to the rules. It's a lot like a well-oiled machine, where each part has a specific role to play, but they all work together to ensure the end goal is achieved, and there you have it. This function of processing and validating requests is what makes the Kube API server indispensable. It's the heart that keeps the Kubernetes ecosystem alive and ticking. It's the silent hero, working behind the scenes, ensuring that our applications are deployed, managed, and scaled effectively. In any system, security is paramount, and the Kube API server is no exception. When we talk about security within the Kube API server, there are three key aspects that come into play: authentication, authorization, and admission control. These three steps work in tandem to ensure that only valid and authorized requests are processed, fortifying the system against any unwelcome intrusions. Let's start with authentication. This is the first line of defense. When a request comes into the Kube API server, it doesn't just blindly accept it. Oh no, the server first needs to verify the identity of the requester. It's like a digital handshake, where the server asks, "Who are you?" The authentication step can use various methods like certificates, password, or tokens to confirm the identity of the requester. Next, we move on to authorization. Now that the server knows who's knocking at the door, it needs to decide if this entity has the necessary permissions to access the requested resources. This step is akin to checking if you have the right key to open a specific door. The Kube API server uses role-based access control, or RBAC, to decide who gets to do what. Finally, we have admission control. Even if a request has been authenticated and authorized, it still has one more hurdle to cross. Admission control is like the final quality check that ensures the request aligns with specific policies set for the cluster. It's like a bouncer at a club, making sure you comply with the dress code even if you're on the guest list. Altogether, these three stages form a robust security framework for the Kube API server. They work together to ensure that every request is scrutinized, every action is validated, and every policy is enforced. It's a bit like a well-coordinated dance, where each step is crucial to the overall performance. These security measures ensure that the Kube API server is not just efficient, but also secure. The Kube API server may seem complex, but it's a testament to the power of well-designed software. This is the heart of Kubernetes, the central point of management and communication. It's the conductor of the orchestra, ensuring that all the different parts work in harmony. In terms of architecture, the Kube API server displays a robust and scalable design. It efficiently handles requests and ensures smooth communication between the various components of Kubernetes. When it comes to functionality, it's the primary manager of Kubernetes resources. It validates and processes requests, ensuring effective orchestration of containers within the system. Security is another key aspect. Measures like transport layer security for client connections and role-based access control for authorizing requests make the Kube API server a secure and reliable platform. So the next time you interact with Kubernetes, remember the vital role of the Kube API server in making it all happen.